Hey, student, how are you? Welcome to our session on the square root function and graph. We're going to take a look at the square root function, the domain, and the range. Then we'll take a look at some transformations of the square root function and graph. All right, here we go. We have the square root of x. And when you take the square root of a negative number, the square root of a negative number is an imaginary number. For example, the square root of negative 25 is equal to 5i, or negative 5i. So we're not going to work with imaginary numbers. We're going to start with 0. And we'll put 0 into our function. Then we get the square root of 0 is 0. And there's our starting point. And we'll put 1 into our function. Square root of 1 is 1. Square root of 4 is 2. 4 comma 2. And the square root of 9 is 3. 9 comma 3. And we'll graph those points. Starting with 0, 0, 1 comma 1, 4 comma 2, and 9 up 3. And here is the curved shape. There it is, our square root function. The domain. The domain includes 0, so we use a bracket to include 0, bracket to include 0. And the range is also including 0 and goes to positive infinity. So this graph goes to the right forever. That's our domain, x values. And then this graph does increase up. So the range does go up. All right, moving on. Let's take a look at the domain of our square root function. And the domain of our parent function is all numbers greater than or equal to 0. Greater than or equal to 0. So in order to find the domain of a transformed square root function, we will set the radicand, the terms under the radical, set the radicand greater than or equal to 0, and solve. Let's take a look at these three problems. We'll find the domain. Number 1, to find the domain, we'll set the radicand, the terms under the square root, greater than or equal to 0. And then we'll solve. We'll subtract 5, bring it over to the other side of our inequality symbol, and we get our domain. X is greater than or equal to negative 5. You could also write that using interval or set notation, bracket to include 5, and then we'll go to positive infinity. Number 2, to find the domain, we'll set the radicand, the terms under the square root, greater than or equal to 0. X minus 7 is greater than or equal to 0. And then we'll solve. Add 7, bring it over to the other side of our inequality symbol, and we get our domain. X is greater than or equal to negative 7. Could also use the bracket negative 7 to positive infinity. Number 3, finding the domain, we'll set the radicand, the terms under the square root, to greater than or equal to 0. Greater than or equal to 0. We'll add 9 to bring it over to the other side. 4x is greater than or equal to 9. And then divide by 4. 9 divided by 4 we get 2¼ So x is greater than or equal to 2.25 is our domain for number 3. Let's take a look at the graphs that go along with each of these. So here's number 1. We found the domain is x greater than or equal to 5. And you can see that our graph is shifted to the left 5. So instead of starting at 0, 0, we shifted to the left 5. Number 2, notice that we shifted to the right 7. Instead of starting at 0, 0, we now started at 7. And our graph goes off to the right to positive infinity. And number 3. Number 3, you could rewrite this square root of 4x minus 9. I could factor out 4. And I would be left with x minus 2.25. So now you can clearly see that we are shifting to the right 2.25 to get to our starting value, and then the graph continues off to the right. Moving forward, let's take a look at transformations, speaking of shifting to the left and to the right. Here is the general form of our square root function. Starting with A, when A is negative, the graph is vertically reflected over the x-axis. When A is greater than 1, we have a vertical stretch. And when A is a fraction in between 0 and 1, we get a vertical compression. Horizontal shift is going to affect the domain. When you have x plus a number h, this shifts the graph to the left. As we saw with our first example, x plus 5, we shifted the graph left 5. Horizontal is the opposite of what you think, and it's when it's under the square root. X minus h shifts to the right. And then number 3, this is the one I was talking about. You can factor out the 4 so that you can clearly see x plus or minus h. The 4 under the radical outside the parentheses is a horizontal stretch or compression. A vertical shift plus or minus k on the outside of the square root. Plus 8 on the outside shifts it up 8. Minus 3 on the outside will move the graph down 3. You can always pause the video if you would like to write this down in your notes. Let's take a look at 3 examples. And that'll do it. Last 3 examples describe the transformations, then find both the domain and the range of this square root functions. All right, number 4. I see that I have x plus 7 underneath the square root. That's going to shift the graph to the left 7. So our domain will be bracket -7, infinity. Shifted the graph to the left 7. You can also set the radicand greater than or equal to 0 and solve. X is greater than or equal to -7. Let's take a look at the range. -13 on the outside of the square root is going to move the graph down 13 units. So now our range will start at -13 and go up to positive infinity. So we've got our transformations, shift to the left, down 13, domain and range. Number 5. Underneath the square root, I see that we have a greatest common factor of 2. let's factor out the 2, and then you can clearly see the x minus h. The x minus 1 under the radical is going to shift the graph to the right 1. So now our domain will start at 1 and go to infinity. The 2 on the outside of the parentheses under the radical will be a horizontal stretch or compression. The plus 5 on the outside of the square root will shift the graph up 5. So our range will now be 5 to infinity. And number 6, we have a out front is -3. And this is going to reflect the graph over the x-axis vertically. And the 3 will stretch it by a factor of 3. So now, instead of the general shape of our graph going up and to the right, we're going to be reflected over the x-axis. So we're going to go down and to the right. So this reflection is going to affect our range reflected over the x-axis. Let's take a look at the x plus 8 under the radical. That's going to shift the graph to the left 8. So our domain will start at -8 and then continue to the right to positive infinity. You can always graph these on DESMOS to take a look at them. Actually, I think I have them after this. And then our range, -2 is going to shift the graph down 2. So then our range will start at -2, and rather than going up to positive infinity, we're going to go down to negative infinity. Oh, so I should switch those. Negative infinity is less. Negative infinity goes on the left. Left is less. Up to -2. And let's take a look at the graphs of these 3 problems, and we'll be done. And there you go. There is a visual picture. A visual picture of our graphs, our domain, and we see that this one has been reflected over the x-axis. So our range was affected. That concludes the square root function and graphs. Thanks so much for joining this session, and I'll see you next time.